presenting on confidential AI and auctions through Dynamic MPC. Thank you.
This one?
And the one that one goes back.
It doesn't work. So just the middle one? Just the middle one?
Yeah, and the bottom one goes back.
Okay. Hello, everyone. So this is Payman from Fairblock. And okay, so after 16 years after Bitcoin, we've achieved God's level meme coin infrastructure and projects, and they're great. We all love them, but it's hard to see that the next 16 years it would be all about meme coins. And I think a lot of blockers for the infrastructure and the projects that can bring more value to the users, or like simply applications that are blocked, are because of confidentiality. And basically confidentiality doesn't necessarily mean things like privacy or tornado cache. It's like simply systems or applications that in their like common sense logic there is like some elements of encryption or like simply controlling the information flow. And there is like all kind of projects working on different technologies to achieve confidentiality for different applications, and it's quite confusing that which technology is better, which is like the go-to solution. So today I'm trying to just like hopefully map like a better big picture about the whole like different cryptography techniques, like, and give you some ideas about like applications that I'm personally excited about. So for good or bad reasons in crypto, like a lot of projects are trying to say that we have the solution for everything that needs confidentiality. So like this solution is what like 42, the answer to all of the problems in the universe. And simply like historically speaking, there is no like 42, the answer to all of your problems, and there is all kind of trade-offs. So I call it the UPS dilemma. So like U stands for like use cases, the application that you want to solve. So for example, it can be confidential AI, like confidential auctions, or basically private transfers. The P is performance. So in terms of delay, bandwidth, overhead, how many messages you are sending, like the time on your user side, in the backend side. So there's all kind of performance overheads. And the S is security. So security, it means like in terms of economic security, how much security your committee has, or like cryptographic security, like what are your assumptions? Is it based on like TE or like hardware security, or is it based on dishonest majority, honest majority, and like ZK assumptions? So there is all kind of different security assumptions or a mix of them. And yeah, in my view, like general purpose solutions that solves everything is a PSYOP. It's really easy to sell the idea that we are building something that solves all of the problems and don't worry about that, but the reality is that unfortunately it's not that easy. And I call like two categories, like dynamic confidentiality solutions and static confidentiality. So in general, solutions like TFHE, I think, are not optimized for most of the applications, but like they are really good as a like general purpose applications or like ZK VMs. But like you can have like some kind of a specific solutions that are specialized for each application. And there is like dynamicity. And dynamicity basically means that if you have like different applications, how you can find like a middle ground with the UPS dilemma that I described, and like optimize the solution for that application. So a very good example of that is like in Bangkok, we have like motorcycles, we have like, I don't know, metro, like cabs, and you can walk. And you know that like for some events, it's better to walk, for some events, metro is better, and for some events, cab is better. And there's all kind of trade-offs. So if you really want to go fast on performance, you go with the motorcycle, but you may lose your job and your life probably. And yeah, and sometimes if you want to go really far, like to the airport, or really, really performant in the middle of downtown, you combine solutions. So I call it like multimodal cryptography. Or like if you watch like Attack on Titan, there is like 3 levels of like walls, and you're in the city, and all of these like solutions can combine, and either for like more secure systems or more performance systems. So I can give you like some examples about that. So like obviously starting with MPC, many MPC solutions are based on honest majority assumption, and there is like the assumption that all of these like n parties like are not colluding with each other, and if t+1 out of n validators or like committee members are colluding with each other, there is normally no way to see like who are the colluding parties and slash them. There are very recent works like by Dan Bonnell and tracing algorithms that are yet to be implemented. If we have that, it would be a solved problem. But for now, the only way to actually make it much, much harder, like practically impossible, not theoretically impossible, is using TEs for each of the validators. So this is like a really beautiful way that MPCs and TEs can complete each other. The interesting thing is that TEs and MPCs with each other can go back and forth. So right now, like TEs can complete MPCs, but also MPCs can complete TEs. So like even in like 20 years, if you want to have like actual TEs that are like secure enough, you can use MPCs to secure them. It's like deeply technical, but I just want to mention that. And with ZK, it's like more interesting for me because ZK's like fundamental limitation is normally private input composability. So for most applications that there is like multiple parties involved, it can be a simple game or like an auction or anything related to DeFi that people should collaborate with each other, or you can compute over them. It's not just about like an individual. You need the like shared private estate. So ZK is by default limited with that because you can prove something about the data in your hand, about the computation in your machine, but you can't like combine the private data and compute over them, right? So things like MPCs or like FHE can be used for that. But in the same time, you still, in some applications, not for all, but for some applications, you still need to prove that the data that you are providing is like valid, it's like kosher. And you can use ZK for that. And interestingly, you can also use ZK to like filter invalid data. Like it can be for performance, right? So you can play with all of the trade-offs here, introduce more complexity, but like it can potentially make your system more secure and performant. And the last idea is FHE. Of course, like FHE, there is no like one solution. There is like things like CKKS, there is TFHE. So like CKKS can be like, in some cases, much better for AI itself than TFHE. TFHE can be like more like accurate for some applications. So if you choose your FHE scheme first, that's like the first choice. Then you, like at least in crypto, if you really want to have like a decentralized system, you need to combine it with threshold decryption. And the threshold decryption is basically the MPC. That if you really want to make it really secure, you combine it with the TEs. So it's like a good example of that in our real world. Normally passwords are just fine, but it's like a very important thing, you combine it with like a SMS, but SMSs can be also hacked, so you have like the code authenticators. So it makes the UX or like development much harder, but like sometimes it's required. And yeah, let's talk about a couple of applications. Personally, the thing that I found very exciting inside Web3 and privacy or cryptography and confidentiality is like it's one of the very few areas that privacy is not like a luxury or like only a social value. Privacy basically can make the whole system more efficient for the end users, and it can provide like basically better welfare. And this is like, I haven't seen this like in a very direct way in other industries, but here, if you can have like prevent MEV, in the Flashbots presentation, you see all of the intermediary like people who are extracting value from you, right? So if you can protect like just not letting it happen in the first place, there is like some money saved in your pocket before being exposed to all of the intermediaries, right? Or if you are putting a limit order or like your option on a perpetual like protocol, like there are all kind of people who are watching the mempool or watching the orders to force liquidate you or like all of the other ideas. And even more interestingly, if you are designing some kind of infrastructure like MEV infrastructure or like the liquidation auctions or like pre-confirmations auctions, game theoretically second price seal bid auctions are more incentive aligned for the bidders, right? And it's impossible, at least to the extent of my knowledge, to make a like centralized seal bid auction, because always there is a centralized auctioneer that like says that, oh, there is a bid from the chandelier, and they can shield the whole like auction, and they can censor the bids from like other people. And academic like research says that we should build like an auction which is encrypted or sealed, and like second price, and with a public broadcast, which is basically a decentralized auction with a blockchain. So it's a very interesting use case that you can use systems like FHE or like MPCs. There's all kind of trade-offs, but maybe like FHE is an overkill. You can use like a simple MPC. But if you use things like identity-based encryption, you don't have like post like execution privacy. It's just pre-execution privacy. So I mean, like there is a lot of technical details here that is like too complex, and my whole point here today is that we shouldn't focus on the general purpose application. We should be, like try to think about like all of these single applications and try to find like what's the best approach for each of them. And the other application that I've been personally very curious about is that like finding out the truth behind crypto and AI, if it's just a meme or like it actually makes sense. So far, the things that I've been like I'm more confident about the reality of them is not running like AI on a chain, is more about like, I call it access and incentive layer, because like one of the most important, like the first problem is basically data. So we've reached in the like I don't know, era that like there is like less public data, and there's either less monetary value or incentives for people or institutions to bring their private data, or there is basically like regulations from the governments that doesn't allow people to monetize their data or like other people's data that is already leaked to them. So if you want to build like a decentralized system that like data vendors or like private users want to bring their data and monetize that, and you don't hit regulatory privacy issues, you can use blockchain. So projects like Vana is using TEs, like projects like us, we are using MPCs. Again, there is trade-offs. And the other idea is obviously like confidential compute. So it's not just about AI. With things like MPCs or TEs, you can run models on top of private inputs in a way that your private inputs are not exposed to the model, and the outputs can be also not exposed to the model or like publicly, it's just for you. So like a typical example of that is like when you want to submit your DNA to a company and the company wants to run a model on top of that, you don't really want to like leak your DNA to the company, but they also don't like we have like closed AI, right? They don't want to leak their own models to the public. So it's more about aligning the incentives of people here and making sure that there's not going to be any problem on the privacy side. And I don't personally like to talk about these kind of ideas that will be relevant in 30 years, like healthcare and insurance. I think it's more interesting to find ideas that is more relevant in DeFi. One of the ideas that I like is basically resource allocation. So there's like strategies, for example, on lending markets and like Morpho. Like naive strategies are not as performant as before. So there's a lot of users that want to get some kind of computations and analysis, and you can basically use AI or any kind of convex optimization. And those models have two inputs. One input is your private input, your risk tolerance, your history that you don't really want to share it with the model. And there is also like things like Bloomberg Terminal and all kind of things like Dune that they also want to monetize their services and data. And you can run models like RAG-based models, like machine learning models, or basically simple decision trees in a way that you are not leaking any kind of private inputs to the model, but the result is encrypted for the end user, and they can use that. So this is also an interesting example that having confidentiality means money, because you can have like more strategical decision for your allocation of funds. And there are also some kind of limitations and dynamicity in terms of where you want to do the confidential compute or like cryptography. There is no clear answer or the best answer again. I call it like two things. There's two options basically on high level. The dining experience, like a restaurant, when you go to the restaurant, you have like the hot food like pretty fast and accessible. And like a lot of people prefer that, but we also have the option of delivery, right? So if you have like a pretty big party somewhere else, you want to call them to, or if you're just like limited for some reasons as a developer, as a user, you can't go to the restaurant, right? So we have the same concept in blockchains. We have, I call it isolated privacy chains. We have like numerous isolated privacy chains that they are very, very performant and beautiful as long as you are going to them and convince all of the users to go to their ecosystem, which is pretty hard to convince the users and the developers. So, but there is also some kind of new, very niche applications that are new, like you can convince them to build, or like applications like HFT style applications that should be very, very performant and fast and cheap. So for those applications, it makes sense to have it in your own chain or your own like L2, and it doesn't have any technical complexities or delays or frictions and other risks like security risks. But if you want to have access to confidential compute on Ethereum or like Arbitrum, where there is a lot of liquidity and users, for operational reasons or like technical reasons, there is no way to actually do that inside Ethereum today, right? So we have all kind of projects like named, like categorized by Vitalik as co-processors. So there is like TEs, ZK provers, like MPC projects that are somehow co-processors, right? By co-processor, I just simply mean that there's like cryptographic operations or like all kind of heavy operations or like multi-party operations that are not possible on the Ethereum side, and you can take care of, like abstract away the computations in your own chain and send the good parts to the Ethereum side, for example, right? But this approach is not just like one single approach. There is again like trade-offs and different methods. There's one approach, I call it like full co-processing, which is basically you send your private input somewhere, but you fetch them and compute over them, and you send the end decrypted result to the private chain, like to the public chain like Ethereum. So obviously this is like easier. It doesn't have any like, you don't need to install any precompiles or like install any like fancy smart contracts or pay for a lot of computations on Ethereum side. But there is a problem of the friction and the fragmentation, right? Because you need to verify that what has actually happened on the coprocessor, and then you probably need like eigenlayer to prove that something has happened, or like another ZK proof to verify your like, claims on the other side. So it gets like more and more technical. So like FHE coprocessors has like normally this kind of problem, because you need to prove that the actual FHE computation has happened on the coprocessor correctly. The other approach is precompiles. So we can have you can have like very efficient precompiles for like cryptographic curves like BLS 12381, and have like MPC operations or like FHE operations on Arbitrum or like Ethereum. But the reality here is that it's like more of it's not more of an operational problem. It's really hard to go to like Telegram channels of these teams and convince them and put it in their roadmap. And it like in most cases never happens unless they're like an app chain or like a independent new L2 that are more flexible with precompiles. And the last approach that I've recently discovered is the stylus. So with Arbitrum stylus specifically, you don't need the precompiles. You can use like Rust, and you can perform on very secure and performant cryptography without any like installing any additional libraries in the first place or precompiles. So there's three approaches. Obviously the first one is the easiest, but there is like the delay, the friction, and all of the other challenges. The second one is the most performant and fastest one, but you should convince the team. The third one is only like possible with Arbitrum right now. And basically the takeaway for me is that instead of focusing on like moon magic and I don't know, like general purpose cryptography applications that they always change, focus on very specific applications that you want to solve, like for MEV, for confidential AI, for games, and try to find like a cryptographic approach that really nails it down. And then at the end of the day, we can have like a lot of solutions that we can combine them in a single network. Thank you.
All right, next up we have Ellie.